right, so for your angular velocity lab, we are going to use our constant velocity car that we used in lab 2 with our constant velocity lab. And we're going to tie it to a string. So you need a pretty long length of string, probably at least a meter. And the first thing that you're going to do is tie it around your car. So you're just going to tie it so that you can hang your car from the middle. You want it more or less balanced. It'll be a lot easier to take data if you can hold it up like this and it's more or less balanced. So in the center of your car. And then all you're going to do is you're going to measure out a length of radius. So from your car, from the edge of your car to wherever you're holding it, that's your radius. And I'm going to hold it that long because I don't think it'll fit. So from here to here, measure this. That's the radius that you're going to do. Then you're going to turn your car on and just hold it so that it goes in a circle. Now he tips over. You'll just have to kind of get used to how to hold it. You do want to make sure that this stays the same. That little bump is getting just like this. And what you're going to do is time how long it takes to go in one complete circle. And that's your data. And that's really all the data that you're going to take. And you're going to do that for 3 different radiuses. So go this far, this far, this far. It doesn't matter how long. Just measure 3 different ones. Take the time it takes to go in one complete circle. And that's your data. So in our angular velocity lab, we are calculating several different things from our data. Now, we didn't take very much data. We measured the radius of our circle, and we measured how long the time that it took for the car to go around that circle. So we really only have 2 pieces of data, but we can find out a lot about our vehicle based on this data. So to find linear velocity, that's the first objective, is to find the linear velocity. We need to take the distance that the car travels around the circle and divide it by the time. Now the distance traveled in meters is equal to the circumference, which can be found by multiplying the radius by 2 pi. And we measured our radius. My radius, I'm just going to put this up here. My radius was 1.57 meters. So that's how big my circle was. So it's a pretty big circle. You probably didn't have one near that big. And at the time that it took, that period of revolution was 1.7 seconds every time that it went around the circle. So to find that linear velocity, linear velocity is really the same as delta x over t. And in this case, delta x is the circumference of our circle. So this is going to be 2 pi r over the time that it takes to go in our circle. So linear velocity is going to be 2 times pi times our radius in meters divided by the time in seconds for 1 revolution. And then if we calculate that, we're going to get 0.924 meters per second, which is pretty fast for a little car. Now we also want to calculate the angular velocity. So angular velocity, remember, uh-oh, my pen's not writing. Just try this a little bit more. All right, so the angular velocity is the change in, it has to do with how fast we're moving through the circle, so measured in radians. So we're not looking at this distance around the circle, we're looking at this distance that it's swiping out of the circle. So this is going to be the change in the angle in radians over the time. So remember, 1 complete circle is 2 pi radians. Let's label that. And the time was the same, so it's 1.7 seconds. So So we're going to take our 2 pi radians, which is 6.23, I just didn't have to do that, divided by 1.7 is 1, or no, not 1. Let's see, it's going to round up, so 3.70 radians per second. So that's going to be your angular velocity. And then we have our tangential velocity. So the tangential velocity, remember when we drew a circle? Oh gosh, this is going to be a terrible circle. I can't draw circles. So here's a circle. And if we are right here, right, the linear velocity, terrible circle, the linear velocity is that distance around. The angular velocity is this, golly, okay, is this angle here, right? In this case, we went all the way around. The tangential velocity, if this string were to break and this car would just go off this way, right? It would go off with some velocity. This is the tangential velocity. So tangential velocity has to do with how fast it's going in a circle and how fast it's going around the edge. So tangential velocity is going to be the radius times the angular velocity. So our radius is 1.57. And we just found our angular velocity, which is radians per second. We have that up already, so let's take that times 1.57. So our tangential velocity is going to be 5.80. Now remember, radians doesn't really have a label. It's a labelless unit. So what we have is we have meters per second. So those are our velocities. We have linear velocity, we have angular velocity, and we have that tangential velocity. Now the next thing it asks us to find is the centripetal acceleration. So we have centripetal acceleration, remember from our last unit, is going to be the velocity squared. And this velocity is actually going to be this tangential velocity. Okay, so centripetal acceleration is the tangential velocity squared divided by the radius. So we have our tangential velocity squared divided by the radius, which is 1.57 meters. So 5.8 divided by 1.57. Oh, I didn't square it. 5.8 squared. Square this, don't forget to square. Divided by 1.57. There we go. So 21.4. And we have a meter squared over second squared, and then we have a meter down here. So this is going to end up being meters per second squared. So one of these meters will cancel out. Now the last thing it asks us to find is the centripetal force. So centripetal force is going to be mass times the centripetal acceleration. So you'll have to find the mass of your car. Use your spring scale to do that. The mass of my car was 247 grams. Convert that to kilograms, and then multiply by this centripetal acceleration. And so your centripetal force is going to be 5.29 newtons. So those are your calculations for this centripetal, for your angular velocity lab.